Topsoil deposit plan. Creating the topsoil embankments. Of course, removing the topsoil means we need a plan for storing it. Based on the area and the depth of the topsoil, we calculate that about 8,100 cubic meters of topsoil will be stripped. This total volume should be deposited in 2 embankments, where each should be 5 meters high, 11 meters wide at the base, and 150 meters in length. Since we only want to remove it from the excavated area, we can place it within the project area, just outside of the new terrain. One on the west and one on the east side of the excavation zone, just above the topsoil and within the project area. Here is a preliminary plan of the embankments, including the dimensions mentioned before for the width and the length, but also the embankment top, which after a few trials I have decided to trim off 5.5 meters in each end, in order to match better the expected volumes. So let's start by setting the right category we want to work in, and then if you go to layers and to the LAND4 folder, make sure you show only the layers showing the elements you want to work with. In order to have a better visibility in the project, let's hide also the spot levels which define the surface. So in the right folder, let's create a new layer, both for existing terrain subsoil, I will call it SL from the spot levels, but also another new layer for the existing terrain topsoil this time, where we will set or place the spot levels that I used for creating these surfaces. In the next step, we go to category settings and then define or assign the layer to the specific category. So here we decide for each element, and for the spot level layer, we're gonna select the layer we just created and press modify. Then we go to also existing terrain subsoil and do the same operation, assigning the new layer for the spot levels within the same category. Once you press OK, the settings will be stored. Now we can select the elements within these layers and simply hide it for the topsoil and for the subsoil. In this way, we managed to hide the spot levels while keeping the land surfaces all together with the level lines in the plan view. Now we are ready to work with the embankments. So on a quick measurement, we can see that it has a width of 11 meters and a length of 150 meters. Next step is to construct the top of the embankment from one end to another, and then removing 5.5 meters from each end. Then do the same for the embankment on the west side of the project. So let's start the job. First, select the bottom of the embankments and the topsoil and press on the drape function. Now in 3D we can also visualize these lines, which they follow the topsoil. Next step, we want to drape the top of the embankment, but this time we'll use an offset of 5 meters from the topsoil. All these lines are now following the topsoil, except that the top has a 5-meter offset. Having the 3D lines defining the embankments ready, we can use the create land surface function and the magic wand to create each of the embankments. We start with the embankment west and then continue with the one from the east. Having the surfaces ready, we can now select the fills in 2D and change the fill pen. Back to 3D, we can now visualize the surfaces, but also we can see that at the end of each embankment, there is just not enough 3D information in order to model the surface elegant. Therefore, we need extra ridgelines on those ends. Using the create ridgeline function with the gravity tool activated, we can create a ridgeline in between the top of the embankment down to the bottom on the corner where information is missing. To create this line, start with one click and end with a double click. Using these ridgelines, we will obtain a more precise model. Now these ridgelines can be visualized in the 3D view, and as you can see, they're not yet part of the surface, they're just created. And the next step is to select them all together with each surface and then press on the function button, which will add them to the surface. Do the same steps for the other embankment. And then we can visualize the final result in the 3D view. We can now continue by selecting the surfaces and access the land surface settings and set a surface for the embankments, but also the level lines for both 2D and 3D with the same height distance. We are now done creating the embankments, which are placed right on the topsoil. In plan view, the newly created ridgelines follow the settings set in the ridgeline settings for the line type and line pen. However, you can always change that afterwards. We can finally now check the volumetrics of the embankments. Start by setting the right category, press on the function button. First surface is the topsoil and the second surface is the embankment west in this case. Define the geometry with a magic wand and place the stamp. Here my layer is hidden, volumetrics layer, so I will show it. Then the volumetric stamp will be shown. Do the same operation for the embankment set on the east side of the project. Having both volumetric stamps available, we can now observe and compare the results, where each embankment holds a little under 4,050 cubic meters, which was the targeted volume for each embankment, which means we are able to deposit roughly 99.5% of the topsoil we initially planned. In the 3D view, we are able to visualize the volumetric surfaces. We need to show the volumetrics layer where they are placed. And we are also able to read values using the LAND4 gravity tool along these surfaces. In order to understand better the embankment's placement, let's place a few sections. Let's start with a cross section. But also a longitudinal section all along the embankment. The topsoil deposit plan is now done. In the next chapter, we'll continue creating the final plans of the project.